Hi friends, welcome to Veteach. In this session, I would like to explain you about realization of IIR filters, infinite impulse response filters. This is very easy topic and very important topic. So realization means drawing the diagrams like block diagrams. Okay, so for drawing this kind of diagrams, we need to understand what are the basic building blocks. So the basic building blocks are, this is the first block, Z inverse block. That means if x of n is passed through this Z inverse block, the output will be x of n minus 1. That means the sequence is getting delayed by 1 unit. Then you very well know about this block. This is summing block. Let me call this one as x1 of n. This is x2 of n. Then the output will be x1 of n plus x2 of n. This is summing block. Then we have one more block. It's like this, arrow mark. If this is x of n and if I write down this arrow mark value as a, the output will be a into x of n. I can call this one as multiplier block, multiplying element. Okay, 3 blocks, that is unit delay block Z inverse, multiplying block A, and then summing block. So with these 3 blocks you can draw the diagrams of IIR filters. So for realization of IIR filters we have 4 methods. The first one is direct form 1. Second one is direct form 2. Third one is cascade. Fourth one is parallel. So we have 4 realizations: direct form 1, 2, cascade and parallel. Now looking into this direct form 1 realization, and you know the basic equation of linear constant coefficient difference equation is like this, and this capital N is the order of equation, that is y of n terms. And here I have given you example also. If n equal to 2, m equal to 2, the equation will be like this if you simplify this. Okay, and in this equation equate all the input terms, x of n terms, to w of n. Then the expression reduces like this. Okay, w of n is the sum of all input terms. Now for drawing this diagram, just very simple, just 3 dots like this. First dot name is x of n, second dot name is w of n, third dot name is output y of n. And see, first let me complete this part, x of n and y of n. You have an expression here, w of n equal to b naught into x of n. So this is x of n. I am multiplying this x naught of n with x of n with b naught. So after this b naught you will get b naught into x of n. I am giving that to summing point. Okay, next I need to get x of n minus 1. So this x of n is sent through Z inverse block. So what will be the output here? X of n minus 1. And this x of n minus 1 should be multiplied with b1. So I am sending this to b1. So this one will be, output will be b1 into x of n minus 1. That one I am giving to summing point here. Okay. Then I need x of n minus 2. So already we have x of n minus 1 here. This x of n minus 1 is sent to another unit delay block, and the output here will be x of n minus 2. And this x of n minus 2 should be multiplied with b2. So multiply with b2 and you give this to summing point. What will be the output of this summing point? b1 into x of n minus 1 plus b2 into x of n minus 2. Already this 2 you are getting here. And this 2 are added to b naught into x of n, and that output is nothing but w of n. Okay. Now let us see this statement. This is the statement: y of n plus a1 into y of n minus 1 minus a2 into y of n minus 2 equal to w of n. Already w of n is there here, y of n is there here. If you want to find y of n minus 1, so y of n, here you will get y of n minus 1. And this y of n minus 1 should be multiplied with minus a1. So you are multiplying with minus a1. So what will be the output here? Minus a1 into y of n minus 1. You are given to this summing point. Okay, then y of n minus 2. Give this y of n minus 1 to this block. You will get y of n minus 2. And this y of n minus 2 is multiplied with minus a2. Multiply with and give to this. And the output of this summing point is the combination of these two. a1 into y1 of n minus 1 plus a2 into y2 of n minus 2. And this 2 must be added to y of n. This 2 must be added to w of n. Suppose if you send this 2 to this side, you will get like this, y of n equal to, here we have w of n, and if you bring this like this, a1 into y of n minus 1 plus a2 into y of n minus 2. That means w of n is this part, here this is w of n, and y of n, this is y of n. If it is sent through this block, it is y of n minus 1, and that should be multiplied with a1, and y of n minus 2, this is y of n minus 2, that should be multiplied with a2. Okay, and after multiplying this 2, you need to add this 2 with w of n. This is w of n, add this, and the output is nothing but y of n. So this is direct form 1 structure. So in direct form 1 structure, how many delay elements are required? 1, 2, 3, 4. Why? Because in this example, n equal to 2, m equal to 2. I will show you. This is the expression, n equal to 2, m equal to 2. That means the number of delay elements required is n plus m, 2 plus 2, 4. So more number of elements, the circuit becomes complex. That is a drawback here. Okay, there is an example here. Same, you can simplify this. The expression is given like this. Equate all x of n terms to w of n. Then y of n equal to this part. And here also the same thing. X of n, w of n, y of n. So x of n and y of n, this is the expression. So 3 into x of n multiplied by 3. And x of n minus 1 is multiplied with 3.6. 3.6. This is x of n minus 1. And x of n minus 2 is multiplied with 0.6. Add all this, you will get w of n. And see the expression for y of n and w of n. This is the expression. So based on that, y of n, this is y of n minus 1, this is y of n minus 2. Simplify, y of n minus 1 into minus 0.1, y of n minus 2 into 0.2. Add all this and add that one with w of n, you will get y of n. This is direct form 1 structure. Now coming to direct form 2, here what to do is, this is the linear constant coefficient difference equation, and from this equation you try to obtain y of z by x of z, and then this y of z by x of z you can write down like y of z by w of z into w of z by x of z. That means if you cancel this 2, again it is nothing but y of z by x of z, and this y of z by w of z equal to numerator. Okay, again cross multiply this and apply inverse Z transform, you will get an expression like this. Then w of z by x of z, w of z by x of z is equal to 1 by denominator. Already numerator is taken for y of z by w of z, and this part is nothing but 1 by denominator. Cross multiply, apply inverse Z transform, you will get an expression like this. So in this expression, there is a relation between w of n and x of n, and in this expression there is a relation between y of n and w of n. Now let us take an example and see how to solve this. This is an example, whatever we have done as example in direct form 1, this is the example what we have taken, and here n equal to 2, m equal to 2. So how many blocks, how many unit delay blocks are there? 1, 2, 3, 4, 4, 2 plus 2. But in direct form 2, let us see whether there will be any reduction in those blocks. So same example I have considered. Okay, I have applied Z transform on both sides and y of z by x of z. This y of z by x of z, they can be written as y of z by w of z into w of z by x of z. And as I told you, this part is equal to numerator. I have written here. Okay, again cross multiplying, you will get like this. And if you apply inverse Z transform, this is the expression. This is the expression. Similarly, w of z by x of z equal to 1 by denominator. That's what I have written here. 1 by denominator. Okay, again cross multiply these two, you will get this expression. Apply inverse, you will get this expression. This is the expression. So for these two expressions, let me show you the diagram. This is x of n, w of n, y of n. Put three dots. Okay, and see the first statement, the relation between w of n and x of n. W of n equal to x of n plus 0.1 w of n minus 1 plus 0.2 w of n minus 2. Since this is w of n, if I send this to z inverse block, I will get w of n minus 1. And if I send this to one more z block, I will get w of n minus 2. And w of n minus 1 is multiplied with 0.1. W of n minus 2 is multiplied with 0.2. And these two must be added. That's why there is a summing block here. And after adding these two, thus 2 must be added to x of n. There is a summing block here. So output of this is w of n. Now move to this. Y of n equal to 3w of n plus 3.6 w of n minus 1 plus 0.6 w of n minus 2. So already this is w of n. So multiply with 3, you will get 3 into w of n to this summing point. And what else do we need? 3.6 into w of n minus 1. Already w of n minus 1 is there here. You multiply with 3.6. Already w of n minus 2 is there here. You multiply with 0.6. Add all this 2 you add here. And after adding this 2, you add with 3 into w of n. You will get y of n. This is direct form 2 structure. So what is the difference here is, in direct form 1, m plus n delay elements are required, but in direct form 2, maximum of n comma m. Of course here n and m value both are 2. So maximum of n comma m. So since both values are 2, you can say here only 2 unit delay elements are required. And this direct form 2 structure is called as canonical structure, and direct form 1 structure is called as non-canonical structure. Okay. Likewise, we have cascade and parallel. For drawing the cascade and for drawing the parallel, you need to know about direct form 2 only. So direct form 2, in cascade form, it will be like first block, second block, third block, like this. In each block, direct form 2. Direct form 2, direct form. Cascade means one after another. In parallel form, it will be like this, one by one. And all the relations should be direct form 2 methodologies. We will see those problems also. So in this class, you learned about direct form 1, direct form 2, realizations of IIR filters. Thank you.